So we're now back to the main menu, and where we are is that we have 3 disks in an underlying RAID Z redundant storage pool configuration with a single file system which has been allocated to that storage pool, and that effectively has 267 gig available to it. So skipping past the properties and hierarchy menu option, we're going to now start looking at ZFS snapshotting and rolling back. So at the moment we don't have any snapshots on this system, and effectively what I'm going to do over the next few moments is I'm going to create a file within Pool 1 Home, and the menus that we've created here allow you to do that, but they're just effectively using standard Unix-based commands to create files. So we're just going to use mkfile, and then we're going to create a snapshot of Pool 1 Home, of that file system as it stands when we have a single file embedded in it. I'm then going to create another file after that snapshot of a slightly different size so that we can better understand what's going on. And then I'm going to create a second snapshot which represents the file system with the 2 files created. And then once I've done that, I'm going to destroy the first file, leaving the file system in a state that we haven't seen yet. And then we're going to have a look at what that's actually done to the snapshots, and hopefully from this we'll start to understand how space is actually allocated during the snapshotting process. And then finally I'm going to roll back to the second snapshot, so that will restore both of the files. So first of all I'm going to write a file to the file system. So I've used option 5, and I want to create a file in Pool 1 Home. We're just generating a makefile command here, and I'll say 500 meg because that's a good size to demonstrate send and receive later on. I'll just call it file 1 for simplicity. So it's just makefile 500 meg, and then that's actually going to be placed in /Pool 1 Home file 1. So just run that command. Let's just press return to regenerate the output, and as you can see now we have 500 meg of used space in the storage pool, and that's residing in Pool 1 Home. So now I'll create my first of the snapshots. So I'll select option 2, and the name of the ZFS file system we want to snapshot is Pool 1 Home with no preceding /. So we're not talking about the mount point here as far as the command is concerned. We're talking about the actual file system name, and I'll say Wednesday because that's today. And there are no descendant file systems, but if I wanted to actually snapshot all of the data, if I had underlying child file systems here, I would actually have to use the descendant option. In this case I'm not going to use that, and simply the command is ZFS snapshot Pool 1 Home, and then at Wednesday refers to the actual snapshot name, and that's pretty much instantaneous because that's just keeping a record of the way in which the transactional file system looks at that moment in time, if you like. So if we go back to the main screen, we now see that we've got an addition here, Pool 1 Home at Wednesday. There's no space allocated to that because it's just a representation as to the way the file systems stand at the moment. And what it has actually done is reserved the blocks that file is actually using up, so that if we deleted it, the actual file wouldn't be deleted in the underlying, as far as the underlying file system is concerned, although you wouldn't be able to see it from userland, if you like. I'm now going to create a second file, so option 5 again. Again in Pool 1 Home, and this time I'll make it 250 meg so we can distinguish between the 2 files when we look at the used and available space, and I'll call it file 2. So just another makefile command. That's complete, and if I refresh the screen you can now see that obviously we have 750 meg of available space, and that is in pool 1 home, but the previous snapshot that we made before we generated the second 250 meg file isn't referred to in the original snapshot. So as you can see, the original snapshot only refers to the first file, and now there's a certain amount of metadata associated with remembering what's changed since then. So we'll make a second snapshot which will then represent the file system as it now stands, with 2 files totaling 750 meg. So option 2, pool 1 home is the name of the file system, and we'll call it the next snapshot Thursday. And there are no descendant file systems again. So ZFS snapshot, pool 1 home at Thursday. So as you can see, the way in which things have changed now, we've effectively got a second snapshot which is referring to both files, and nothing's changed since that snapshot was made because we don't have any metadata referring to those changes. So now would be a good point in time to destroy the first of the files so that we can start to see how things change within our snapshot configuration here. So this was a lot of fun scripting into these shell scripts using the rm command to delete a file from the file system. So I'd like to delete a file from pool 1 home, and the scripts just show us what's available in /pool1/home, and I'd like to delete file 1. And that just runs an rm command. So now we're at the point where both of the snapshots have had changes happen since they were created. The first of the snapshots refers to the point in time when we only had one file, and the second refers to the point in time when we had both. The blocks that were allocated to creating file 1, the one that we've just deleted, are still reserved and still have that data within it. It's just that you can't see that within the current active tree, which moves all the way back to the Uber block that Tim probably referred to in the previous presentation. So if we at any point in time want to now roll back to a point where we have both files within the actual file system on the actual mount point in Solaris, we just need to roll back to the second of the snapshots, and that would just effectively take us back to a previous representation using a previous Uber block. So I'll select option 7. And I want to restore the second snapshot. And I'll say no, because we don't have any more recent snapshots in this particular scenario. And the simple ZFS command that's run is ZFS rollback, and then the name of the snapshot you want to roll back to. And again, that will be instantaneous because that's effectively just flipping over to a previous representation of some blocks that have been reserved ever since that snapshot was created. So that is obviously returned straight away. We're now back to the point in time where we have 750 meg of use space. So pool 1 home now has file 1 residing in it again, and any changes that were made after the second snapshot was made have now been discarded because effectively we're back at that point in time. At any point during the creation and the manipulation of snapshots, if you look in pool1/home/.zfs/snapshot, we can see a read-only representation of the files that have been reserved as part of that snapshot. And if we wanted to, we could pluck files out of there and use them elsewhere. So that kind of takes us quite neatly on to looking at cloning, which is really a writable version of a snapshot. So you actually create a clone from a snapshot, and it creates a writable version of that representation, which you can then manipulate and promote, and we'll demonstrate that now. So move back to the top level, and we'll select option 5. Currently we don't have any clones, so we'll create a new ZFS clone, and what we'll actually do is we'll create a clone from the second snapshot that we created, so pool 1 home at Thursday. The menu actually asks you whether you want to create a clone from an existing snapshot or create a new snapshot. So that will effectively add the snapshot creation to the procedure. But we don't need to do that, so I'll select option 1. So the name of the snapshot I'd like to clone is Pool 1 Home at Thursday. And I'll call it Pool 1 Home Clone. Again, this is just building the command. The actual ZFS command that we would run would be ZFS clone, the name of the snapshot you want to clone, and then the name of the new clone. So let's run that. That's pretty much instantaneous. And as you can see here in the output, what we've actually got now is Pool 1 Home Clone, which is effectively a writable instance of the snapshot we created earlier on. And it behaves in a similar way. There's no changes been made since we generated that clone, so there's no metadata space effectively taken up. But one difference being that we now have an actual mount point associated with that. Whereas we've got the .zfs/snapshot directory for a read-only look at the snapshot we created, when we generate a clone, we actually can then poke around in Pool 1 Home Clone and change files and then promote those back to being a file system. So the next thing that we could look at is replacing a ZFS file system with a clone, which gives you an example of a scenario where you would want to use the promote command. So I'll select option 3. And the name of the ZFS file system that I would like to replace with a clone is Pool 1 Home. So just imagine for this demonstration, for the purposes of this demonstration, that we've been into Pool 1/Home Clone and we've made changes to that file system, and now we want that to become the main file system. Would you like to use an existing clone of that file system? Yes, because we've already generated it. Again, this is just building a command. And then once that replacement is complete, do we want to destroy the original file system? I'll say no, because I'd prefer to rename it and then archive it as a legacy file system for backup purposes. And then we'll say we'll call the archive Pool 1 Home Legacy. So that's really just the menu sequence generating a series of commands. The actual ZFS commands that are being run as subsequently from that is ZFS promote Pool 1 Home Clone, which effectively promotes that clone to being the main file system. And as you see when we step through this, we'll see what that actually does to the actual allocated space to each of these. And then once we've promoted the clone, we'll just rename the previous file system, which then actually effectively becomes the clone itself, as a legacy file system and for archival purposes. And then we'll rename the clone, which has now become the promoted file system, to Pool 1 Home. So let's step through these commands. So before we run the actual promote, I've just run a ZFS list, which is actually the command that we've been using to generate a lot of this information that you've seen at the top of the screen throughout this demo. Just to see that Pool 1/Home, which has the two files in it, actually has 750 meg effectively of use space, and the clone itself has no use space. So this is a writable representation of the snapshot we made. So if we then press enter and run the ZFS promote command, then press enter again, what has actually happened here is that the clone, Pool 1 Home Clone, has now become the active file system on the same mount point. And one interesting thing you'll see is that the snapshots that we made earlier on have also followed the active file system and now have been renamed effectively and are now active snapshots for the new promoted clone. And the original file system, Pool 1 Home, is now effectively the clone and doesn't have any use space allocated to it. It is effectively behaving like a writable snapshot. So then we simply rename each of those in the way I described earlier on. And then when we go back to the main screen, which takes a couple of seconds, you'll see that what we effectively have done is created a new active file system from a clone that we've played around with offline, and then archived the original file system for backup purposes. And then if you want, you can destroy ZFS clones using the ZFS destroy command. But we'll move back to the main menu here and start looking at sending and receiving. So we'll select option 6, save and restore, and we'll save a ZFS snapshot. So one thing you'll notice before I move on to this is that during this part of the demonstration, I'm going to be moving between the two tabs here at the top of the screen. So currently we're on the ZFS Demo tab, which refers to the X4240 that we've been, X4250 that we've been using. And ZFS Demo 2 refers to an X4100, which has one spare internal disk on it, and is connected just via a standard gigabit Ethernet link. So I'll select option 1. And what I want to do is save an existing snapshot to a remote host, but I have lots of different options here because, as described in the main presentation that accompanies this demo, in actual fact, send and receive just sends streams through standard out. So effectively, we can pipe the ZFS send command into a number of different Unix standard commands. If I wanted to, I could pipe it into a CPIO or a gzip or a tar command, and just package it up to be unpacked using the ZFS receive command later on. I couldn't simply just unzip it and look at it because it needs to be streamed back through ZFS receive. But what we're actually going to do in this scenario is I'm going to demonstrate a command that uses ZFS send to stream through standard out the snapshots that we've created to a remote host which has passwordless SSH set up between the two hosts, and then we're just literally going to use SSH as a second pipe in the command to ZFS receive, effectively unpacking that stream directly onto the second host. In order to do that, we need to manually create the storage pool that we're actually receiving the file system on, or the snapshot rather, before we actually run the command. But we'll go through this step by step. So I'll select option 1. And the name of the snapshot that I'd like to save initially is the first snapshot we made, ZFS, pool1/home at Wednesday. And the reason we're going to do it this way is because I want to demonstrate incremental send and receive, whereby once we've sent the first snapshot, which is a representation of the first 500 meg file, I then incrementally want to send the second snapshot, which will only actually send the remaining 250 meg across to the remote host. So this initial backup isn't an incremental backup. So I'll select no, which then doesn't use the -i handle that we'll see later on. So the username and host name of the remote system effectively is just building the SSH portion of the command, is root at ZFS Demo 2 in this instance. So effectively what the output's saying here is that before we run the second part of this command, we actually need to make sure that the underlying storage pool needs to exist on the remote host before we can send the file system, the snapshot. But the file system that we're going to be calling the send must not exist if this is a non-incremental backup. So on the remote host, I'm going to call the underlying storage pool new pool 1, just so that we can distinguish. And I'm going to continue to call the actual file system /home, but if I wanted to, I could rename that at this point. What I'm now going to do, if you follow the mouse, is actually just step across to the second tab, which has now taken us onto the X4100 remote host. I'm just going to create the underlying new pool 1 storage pool, because if we don't, the send command won't receive at the other end. So I'm going to select option 1 on the remote host, again using the scripts. And as I mentioned, there's one internal disk available, apart from the boot disk itself. And I'm going to call it new pool 1. So I'll just select the spare disk, and that's just created zpool create new pool 1 and the name of the spare disk, which then just gives us 68 gig of usable space, non-redundant usable space. I'm now going to flip back to ZFS Demo, which is the main demo server, and And one thing that you'll notice is that we're effectively moving the file system using send and receive, copying the file system to a remote host which has an entirely different underlying storage pool configuration, which is one of the great things about the design of ZFS. From an administration point of view, we don't really care about the underlying physical devices or how they're made up. We can just shovel file systems from one to the other. So the actual command that we're generating initially for the first non-incremental backup is ZFS send pull1 home at Wednesday, so the name of the snapshot that we want to send. And then we're piping that into an SSH command onto the second host, and we're receiving it using ZFS receive. I've used the shorthand in this particular scenario, and then the name of the new storage pool and the new file system. So when we run that, that'll take a little while because of the sizes of the files that we created. That's sending the 500 meg file across. So I'm going to step across to the second remote host here and press return. And what we'll actually see is that as I keep refreshing the screen, that data is actually coming across. Once that data is completed, it's send across the network. It will then generate a new snapshot which is representative of the file system as it stands in this point in time, which is pretty much identical to the snapshot that we sent from the other end. So I'm now going to move back to the main host. That command's finished. And I'm going to save another ZFS snapshot this time round. I'm going to make it an incremental backup of the second snapshot, which effectively will just transport or copy the 250 meg file from one to the other. So I'm going to save an existing snapshot to the remote host again, as before. This time selecting the second. And this time round, it is an incremental backup. And for the purposes of this command construct, I need to tell it the name of the first snapshot that we used. Again, root at ZFS Demo 2. Again, I need to tell it the name of the file system that we're actually receiving this as. And you can see some subtle differences here. Effectively the same command as before, aside from the fact that we've got the -i option here, the name of the first snapshot we sent, and now the name of the incremental snapshot that we want to send. So -i, first snapshot, and then the name of the incremental snapshot. So if we run that, it'll be slightly quicker this time. We'll step over to the remote host and refresh the screen. We'll start to see the second incremental send coming across. As you can see, there's now changes associated with the original snapshot because the file system is now a second file associated with it. And then when the send is complete, or when the receive rather is complete, a second snapshot is then generated representing the way in which things stand now. So what we effectively have now on both hosts is exactly the same file systems, although created on a different storage pool. They're effectively one and the same, and file 1 and file 2 have been effectively archived off to a remote system. So if I step back to the first host, one of the things that I could actually do here is destroy pull1 home. So if I move back to the top level menu and then select option 12, destroy the ZFS file system, I want to destroy pull1 home in its entirety. We'll force the changes. So ZFS destroy. We probably don't need all of these options, but we'll run them anyway. And we've now rendered ourselves in the situation where we have a 408 gig RAID Z storage pool, but we don't have any data on it. So if I now again select option 6, and this time round restore a ZFS snapshot from a remote host, the menus obviously give you the option to use gzip files for send and receive, but we're using remote hosts in this example. The name of the remote snapshot that I want to restore to this host, let's go back to the remote host for a second here, and we'll grab the second of the snapshots so that we get all of the files that we've backed up in the second incremental backup as well. So we'll say new pool 1 home at Thursday. We'll tell the menus the name of the remote host and the user that we want to use SSH for. And now we have to enter the name of the new file system to restore the snapshot to. And in the same scenario, it's effectively just a reverse of the command we ran before. So it's exactly the same scenario. The storage pool on this host that we're restoring to needs to be created before we run the commands, but the file system itself mustn't exist, only for incremental restores. So in this scenario, it's just pool 1, and we'll call it home again because we want to maintain the naming convention we used before. So as you can see here, now instead of running the send from this host and receiving on the remote host, we're literally just reversing that. So we're running SSH onto the remote host, and from there doing a ZFS send of the previously backed up snapshot, and then we're just receiving it here. So if I press return, gradually you'll see that refresh, and file 1 and file 2 and the 750 meg associated with those files will gradually be restored, and then a snapshot will be generated to represent the way in which the file system stands at that point. If we wanted to maintain the previous snapshot setup, we could have restored the first snapshot first and then made an incremental restore of the second, but we just grabbed the whole lot in one go. So now we're back at a point where we have all of that data available. So if I duck out of the actual menus and go to pool 1 home and then do an ls, you can see that we have both of the files back where they were before we destroyed the actual file system. So just to show you that which I referred to earlier on, if I cd to .zfs and then snapshot, so we're in pool 1 home .zfs snapshot, we can then see a read-only copy of the files that we've effectively reserved the blocks for by making that snapshot as well. So that effectively ends the demonstrations. Hopefully you've benefited from the menus we've created, and that we've successfully demonstrated how simple it is to actually generate file systems using ZFS and administer change properties for those, as well as backing them up. As mentioned, there's lots of other capability here, so feel free to download the scripts and send any suggestions through to myself.